All right, Chapter 9, Set E. The scatter diagram in Figure 7, so that's on page 151, shows stripes. Why does that um, why does that scatter diagram on 151 have stripes? So why does it not look very scattered? It looks like there are a bunch of horizontal lines. I think that's a different question. That's not. Um, it right. Everybody rounded to the nearest year. Yeah, you know you're not going to say 1.86 million years. You're just going to round it, and looks like they rounded it to the nearest even number. So the rounding created the lines. Where in reality, if we truly knew exactly the dates, then it would look more scattered. All right. 2. Is the correlation in Figure 8 ecological? How is that relevant to the argument? So if you go back, so if you go to 149, there's a box, and it says ecological correlations are based on rates or average. They are often used in political science and sociology, and they tend to overstate the strength of an association, so watch out. They're created using averages. So instead of looking at the correlation of everybody, like the whole world, um, so it's the difference between surveying the whole world and plotting everybody on a scatter plot and surveying groups of people that cover the whole world and average each group and then graph the averages. Does that make sense? So you might have this group in the United States, you might have this group in France, and then this group in another country, and then a group that's in there. But if you find the averages, so the average of the blue is right here, the average of the black is right here, and the average of the red is right here, and the average of the green is right here. So this looks very, very correlated. When if you looked at the group as a whole, it's a lot fatter of a football. Does that make sense? So if you average before you correlate, you run the risks of making things appear more correlated than they actually are. So I don't remember what the question said. Um, yeah. So is the correlation in Figure 8 ecological? Yes, because well, it does exaggerate it, but how do you know that graph on 152 is ecological? Each country is an average of their population. So this looks extremely correlated. And I actually have a really neat video I'm going to show you today that talks about the danger of lumping everybody into their country. It's actually pretty cool. Okay, 3. The correlation between height and weight among men 18 to 74 in the U.S. is about 0.4. Say whether each conclusion below follows from the data. Explain your answer. Taller men tend to be heavier. True or false? True. How do you know? What about that correlation tells us that taller men are heavier? So I got a correlation of 0.4. How does that number tell me that taller men are heavier? It does. It's positive. So the regression line has a positive slope. We don't know what the slope is. So we have a scatter plot, and we know it's not very correlated like that. But even though this has an R of 0.4, the fact that that is positive tells me that the regression line is positive. Right, so taller means more weight. Okay, what's something that would be negative sloped? Age of a car and its value. That would be negative slope, so you could get negative 0.4. Now, it's a very weak association, but it's still a positive association. The correlation between weight and height for men age 17 to 84 is about 0.4. True. That's what the correlation coefficient tells us. No, I tried not to. Okay. Heavier men tend to be taller. True, because the slope's positive. Yeah, it's the same as the first question. If someone eats more and puts on 10 pounds, he is likely to be somewhat taller. False. Okay, 4. Many studies find a negative correlation between hours spent watching television and scores on reading tests. Does watching television make people less able to read? It takes time away from reading. So TV itself probably doesn't cause poor reading, but the time that you watch TV takes away from the time that you might read. So does one cause the other? Not necessarily. There's a confounding factor. You run out of time. Yeah. So it might be, if you're bad at reading, you're probably not going to spend a lot of time reading, and you'll probably watch more TV. But when I was a kid, there were people that said TV causes dumb kids. You know, there were ads on TV that told you that watching TV made you dumber. Which, yeah, I saw through that as a little kid. Right? I like to read and I like to watch TV. All right, 5. Many studies have found an association between cigarette smoking and heart disease. One study found an association between coffee drinking and heart disease. Should you conclude that coffee drinking causes heart disease? No. So what's going on here? Coffee drinkers are also more likely to be smokers. And mhm. Well, it's not that people who drink coffee are more likely to smoke. It's just if you were to ask people, do you smoke and do you drink coffee? People who smoke also tend to drink coffee, right? Right, but the percentage of people who smoke and drink coffee is higher than the percent of people who don't smoke and drink coffee. And again, this is not an experiment. This is just an observation, right? It's unethical to make somebody smoke for an experiment. You you might be able to get away with making somebody drink coffee. That might not be too far out there. All right. 6. Many economists believe that there is a trade-off between unemployment and inflation. Do you guys get that? When unemployment is high, then that affects inflation. Low rates of unemployment will cause high rates of inflation. So if everybody has a job, things become more expensive. That's what it's saying. While higher rates of unemployment will reduce the rate of inflation. So if you have lots of people without jobs, then things do not go up in price as fast. The relationship between the two variables is shown for the U.S. in the decades 1960 to 1969. There is 1 point for each year, with the rate of unemployment that year on the x-axis and the rate of inflation shown on the y-axis. The points fall very close to a smooth curve known as the Phillips curve. It is an observational. Is this an observational study or a controlled experiment? Observational. You can't control this, right? You can't control employment and inflation. Both of them are absolutely out of your control. If you plotted the points for 1970 or 1950, would you expect them to fall along the curve? Um, I so we haven't used this word yet, but whenever you see a pattern and you extend that pattern into the future or into the past for times that you don't actually know, that's called extrapolation. And you have to be careful when you extrapolate. Extrapolate means you take a pattern and you extend it into an unknown time. And you can usually get away with extrapolation in the short term, but not in the long term. So you might have somebody who shows you the population of the world for the last 10,000 years, and it looks like this. And they say 10 years from now, we're going to have this many people. I am quite fearful going 10 years into the future. Yeah, you have no idea what's going to happen. So extrapolating is difficult. So it looks like that curve is going to continue. So we have this curve here that ends in 1969. Can I continue that into 1970 or beyond? Or could I go back into the 1950s? Well, what does what does unemployment what is unemployment based on? Well, we had virtually no unemployment during World War II. Everybody had a job in World War II. But 10 years before then, we had high unemployment during the Great Depression. So there are a lot of social things that go into this fact. So I would not trust this line in either direction much at all. Yeah, I would not trust it, especially beyond. Well, I guess you're going 1 year into the future and 10 years into the past. But something as volatile as unemployment, I would be very careful. Um, it just extrapolating is dangerous, especially you only have a 9-year period and you want me to look 10 years in the past. So you want me to go further in the past than I actually have data. It's a longer jump. So no, bad idea.